Welcome back, everybody. This is our video solution to problems 3 and 4 from Quiz 4. This is Fall 2023, Math 307, Linear Algebra at Cal State Fullerton. Like I said, we have two problems here. So the first problem is simply to state the fundamental theorem of linear maps. So this is essentially what most people call the rank nullity theorem, but it's called a little something different in Axler's book. So, hey, let's just do that. So, FTLM. What is this going to say? Well, if you have a finite dimensional vector space, so V here is going to be some finite dimensional vector space. And if you have a linear map from V to some other vector space, so there's no assumption here that W is actually finite dimensional, only that the domain of the linear map is finite dimensional, then we can conclude two things. First, the range of T, okay, which is a subspace of W, is finite dimensional. Okay, and then probably the more important one, the thing we're going to be using all the time, is that the dimension of V is equal to the dimension of the null space of T plus the dimension of the range of T, which of course is why we want the range of T to be finite dimensional, so that this second equation makes sense. And of course, this bit here is what is usually called the nullity, and the dimension of the range is called the rank. All right, so this is the nullity of T and the rank of T. Okay, and this is where the rank nullity theorem name would come from. All right, so that's what the statement is. So then in problem 4, it says if you solve problem 2 correctly, what was problem 2? Well, in problem 2, we had a linear map from R2 to R3. And what we concluded in the end was that the range of that map had a basis of length 2. That tells us that the dimension of the range is 2, or if you like, the rank is 2. And that's the only thing we have to remember, along with that this was a map from R2 to R3. Well, actually, the R3 doesn't even really matter. Okay, so let's copy that down. So for problem 4, we know we had a map S from R2 to R3, and of course, R2 is certainly finite dimensional. All right, and we knew that the dimension of the range of S was equal to 2. So the problem is to use the fundamental theorem of linear maps to compute the nullity, right? So remember, dimension of the range is the rank. So we know the rank, and we want to know what the nullity is. Okay, but the domain is a vector space of dimension 2. So the dimension of R2 is equal to 2. So using the fundamental theorem of linear maps, we know that 2, which is equal to the dimension of R2, has to equal the nullity of T plus the rank of T. And we computed in problem 2 that the rank of T is equal to 2. So we get the nullity of T plus 2. But if 2 is equal to something plus 2, then we conclude that the nullity is 0. So the nullity of T is equal to 0. Okay, but that means that the dimension of the null space of S, I'm writing T here, of course these were S's all along. Yep, there we go. The dimension of the null space of S, there's one more, is equal to 0, which means that the null space itself must be the 0 subspace. And this gets to our 4b question, is S injective? And the answer is yes, because the null space is 0. And we know that a linear map is injective if and only if the null space is 0. So this implies S is injective. And there we go. All right, everybody, we will see you next time.